Example 5. This is the second type of question, and I really only have one example for this type, mainly because this is getting way too long. But obviously, you can have very, very interesting questions when I give you the volume of gas produced and you have to work backwards. But the second type of question in a nutshell is you're given the amount of product and you have to work backwards, work out what is the current that you need, how long do you need to run the cell for. Generally those two. So this is example 5, how long. How long is another way of saying what is the time. And if it say how long, it doesn't have to be in seconds. You can convert it to minutes if it's more sensible, but you don't have to. You can leave it in seconds unless the question specifically asks for a unit of time. How long would it take to deposit 50 grams of copper? So it gives you the mass of the product. Because it's a deposit, you know it's the product. So mass of copper deposited is 50 grams at the cathode of a copper plating. So this is again electroplating cell operating at a current of 8.00 amps. Okay, so essentially this is working backwards, and at the same time I still start with, I don't even know what's happening with that line. I'm still going to start with writing the half equation because I need to make sure that my ratio is correct. So you know that copper 2+ is the oxidizing agent, and you know that copper is the product. So the equation at the cathode, because this is electroplating, is copper 2+ going to copper, and you need to add 2 electrons here. So we're working backwards to find time, which means that I'm going to need to find the charge via electrons first. So step 1 is to find the number of mole of copper, which is mass of copper over molar mass. So 50 grams divided by 63.6, so 0.786 mole. This is going to be the number of mole of copper. And I need to use the number of mole of copper to find the number of mole of electrons. So in this type of question, the unknown is now the number of mole of electrons and not the number of mole of copper. So my mole ratio will be the reciprocal of what you would have seen in examples 1, 2, 3, and 4. And in this case, the number of mole of electrons actually 2 times the number of mole of copper. I'm just going to repeat it one more time, that it is very important to be very careful when you look at mole ratio, because a lot of the time without establishing the ratio and by writing it down, students make mistakes and they don't know whether they're supposed to halve it or double it. And if it's a 50-50 guess, it's not when you want to gamble, I think. And you don't have to, like, it's not supposed to be that hard. Okay, so charge for 1.57 mole of electrons is the same as 96,500 coulombs for 1 mole. I think I was being ambitious, but I don't think I can fit everything in this slide, so I'm just going to go to the next one. So charge over 1.57 mole of electrons. So you're working backwards here. You're finding the charge is the same as 96,500 coulombs for 1 mole of electrons. So you can find the charge, which is 1.57 times 96,500. Okay, 151,729.5556 coulombs. And then from here, you should be able to find the time, which is just Q divided by current. So 151,729.56 over, the current was 8 amps. Okay. So 18,966 seconds. I'm going to check sig fig. 3 sig fig, so 1.90 times 10 to the 4 seconds. I'm not going to bother converting it into minute or hours, but you could if you want to. As long as the conversion is correct, you won't get penalized. That is example 5.